Hello, in this video I'm going to demonstrate you literate programming with continuous testing using ProjecturEd. ProjecturEd is a generic purpose projectional editor that can be used for multiple different purposes. In this case I'm going to use it for programming. This document looks like text. It is not. It is a complex data structure that contains a book with 3 chapters. The first chapter being the specification, the second chapter being the implementation, the third chapter contains a test. The problem we are investigating here is a simple but not trivial one. It's the factorial. As you can see, the specification is copied from Wikipedia. Okay, in the second chapter, in the implementation chapter, there's a Common Lisp function that implements this factorial function using recursion. You might think that this factorial function is some kind of text, but it's not. It's rather capturing the intention of the Common Lisp code, the function definition, function application, constants, variable definitions, and references, etc., etc. And in the test chapter, there's another Common Lisp program that checks the result of the factorial function for all integers between 0 and 10. As you can see, currently there are 9 failures out of 11 assertions. To show you that it really is a structure, there's a specific projection called focusing that is capable of focusing to a small part of the document. When I press Ctrl dot here, the thing that it does is that it shows only that small part where the selection was, and I can still edit and move around and edit this thing. I will show you it later. When I press Ctrl comma, I can go up in the document and show you a bigger part, like the function where that expression was, or even the chapter or the whole book. You know, and the selection still remains at the same place. Another thing to note here is that the factorial function is automatically compiled. The projection that we are using here is prepared to compile the function whenever you change it. And also for the test is also automatically run, so that I can do continuous testing while editing the function. The tests are run and I see the results here. Okay, let's start and fix this function, because I intentionally implemented this function with a number of bugs in it. Okay, the first one is being the name of the function. It's not factorial, it's factorial. So I put an I here. As you can see, all the names changed here in the document. Why is that? It's because there's only one name of that function. So all these factorial strings here on the screen, they are reflecting the very same name of the very same factorial function. There is no refactoring operation when I edit the name here. Instead, it's just simply changing the name that appears in multiple places on the screen. Same thing is true for the name of the argument of the function. But let me show you something. If I press Ctrl dot here to focus in that part of the document and start editing this variable name like num and go back, the thing that you might notice is that all the occurrences of that variable, even though they were not present in the previous stage, are changed. That's because there's only one instance of that variable. There's only one name of that variable. So when I change it, it changes everywhere. Of course, you can change a name in a way so that it refers to something else. That's quite common in programming, but I'm not going to show you this right now. Okay, let's continue fixing the function. What kind of errors are there? Okay, here's this 3. We know that the factorial of 2 is supposed to be 2, so the 3 here is wrong. So I put a 2 here, and now suddenly the thing that happens is not this one is fixed, but instead factorial 3 is fixed. It's because I intentionally put an addition instead of a multiplication here, and it causes this weird behavior. So if I put an asterisk here, the thing that happens that there's an error because there's no such function. So during running the test, most of the assertions were skipped because the factorial 2 caused an error to be raised. The error is an undefined function, as you can see here, and the rest of the test program is just skipped because of the error. It couldn't continue execution. So if I hit a delete here, and suddenly almost all of the assertions pass, except one, which is the factorial of 9. I intentionally put an extra 0 here so that I can fix this in the test program too. So I delete the last 0 here, and then all the assertions pass, all the 11 assertions pass. Another interesting thing to note is that this program, as displayed here on the screen, is just one projection of the data structure behind the scenes, because the other projection that is actually used by the compiler to run this test is obviously ignoring these images here. So the compiler wouldn't be able to do anything with this kind of images, but it's actually in the document, not as an image but as an assertion, and the result of the assertion is projected as an image onto the screen with the current projection that I'm currently using here. Okay, that's it. Thank you for watching.